Hi, welcome to another video in which we'll be talking about another formula to calculate limit of detection that I have seen recently. Okay, before we get started, please pause for a second and subscribe to my channel. I really appreciate that. And let's get into this formula. Okay, the formulas right now is on your screen right now. It say LD is 3 time concentration, time noise, time city, time peak width at half height, which is W half over here, divide the error count, right? So this is kind of like a very weird formula that I have seen recently. I'm not sure how we have this kind of formula, but the way I look at it is very similar to the one that I did before, which is a signal to noise approach. Let me show you that. So signal to noise approach is something like this. LD is threshold, time concentration, time noise divided by height. You know, if you move the noise over here, you have height divided by noise down here. That is actually signal to noise. So if you look at, if you compare these two formulas, you see number 3 over here, that's actually a threshold in our formula. Then we have the same concentration over here. We have the same noise over here. And we just need to figure out why we have 60 time peak width at half height divided by errors, and that actually very similar to height. Let me show you why. Okay, so let's look at this one. Okay, first of all, the peak width we usually measure is in minute, you know. So in order to convert into seconds, you want to time 60 over here. So that's why you have about 60 over there. So 60 time weight at half height, that is you want to convert the one into second. And if you look at the peak, most of the time the peak's like a very nice triangle like that, and the width at half height most of the time it should be very close to the half of the width at the base over here, right? As I say over here, width at half height is a half of the width at base. Okay, and if you remember the formula for, I mean, during secondary school or things like that, a triangle, so the error count of a triangle is half of the peak height times the width at the base over there, over here. So if you put everything in the formula, then you'll be able to get the highest error count divided by width at half height over here. And then if you replace that into this formula, that's actually give you this the formula on top over here. So to me, these two formulas are kind of more or less the same. They should give you very close results, but for some reason they have two different formulas over here. But right, so it's good to know our formula. So if you happen to use the first formula over here, this video is for you. I will show you how to use Openlab Chemstation to perform the calculation automatically for you. In this video, I'm not going to use Excel because the formula is quite straightforward. So you just need to know all this. You should be able to plug in to Excel formula and perform calculation. So I focus more on the Openlab Chemstation Intelligent Reporting, how to perform the calculation with that. Okay. All right. So let's jump right into Openlab Chemstation. Okay. The first thing you may want to do is okay. Let's look at the formula for a while. Okay. You want to have a concentration which is a fixed number because that is the standard, the COA of your standard that you run. So this is should be a fixed number. The noise and the error count and the width over here is it may change from one to another run. So always it's best is to perform a couple of runs. So I would suggest to do at least 3 runs so that you know that they are really repeatable before you really want to pick one of them for the calculation. So in this exercise, in this formula, so in this video, you see that I've done 4 runs over here. Let me overlay all of them. Okay, there you go. So let me close the table over here. All right, so I have 4 runs and I have 2 different responses or different signals over here, A and B over here. Let me show you the A. So I have only one peak on the A channel over here, and the one I'm looking at is CO2. And you see the peak are kind of repeatable. So once they are repeatable, I'm good to pick any of them to perform calculation because they are repeatable. So any one of them should give me very similar result, right? So, but this is the first step you want to do. You want to make sure that they are repeatable, all right? Then you want to perform the calculation, check for your signal B as well. If you have only one signal in your method, that's fine. Just go ahead, just check on one signal. But in this video, the one I'm working with is having 2 signals, right? So this is signal or signal A. And you see hydrogen peak is right here, and they are quite repeatable over here. I'm happy with that. Then just zoom out. Then I will. Okay, double check this. Okay, repeatable looks good. Okay, zoom out. Okay. So again, nitrogen down here is repeatable. Then I have one more pick, which is CO, and that is also repeatable. So you see that this is the first step we want to do. We want to overlay all at least 3 runs, make sure everything's repeatable. So once you're happy with that, you remove the overlay over here, and you just need to rely on one of them to perform the calculation. It doesn't really matter which one, because basically they are very repeatable. So any one of them should give you very similar result. So let's pick the number one over here, the first one, and we'll be using this one for calculation. All right. Okay, so let's go back to the formula out here. We need to have 3 over here, and this is constant, so that's okay. We need to have a concentration. So let me show you where you can store this where you can how to say, store the concentration of the standard you're running in Chemstation. Okay. Okay. First of all, you go to calibration table. Down here. Okay, this numbers most of the time it will be different from the concentration that you're running from your calibration table from here. So if it's different, you don't have to worry. So let me show you that. First of all, you go to calibration, you go to calibration table options out here, then edit options. All right, and then you want to put your cursor somewhere here, and then you want to select something called multiplier, then you move it over down here. Okay, say okay, and you still have a new column called multiplier. Everything is 1 right now. So what you need to do is you enter the concentration that you ran. I mean, in my case, this is the one. This is COA that I ran off this compound, and everything was, I think, was about 10 ppm. So I don't remember exactly the number, but if you have the exact number, just key them in, right? But everything was about 10, so I'm going to key in everything as 10 now here. All right, so this is the first step that you have. So you have concentration, key in, noise as next step that you want to do. In order to come up with the noise, what you need to do is Chemstation will perform the noise calculation for you, kind of not automatically, I would say semi-auto, but provided you let Chemstation know the range that you want to perform the calculation, right? So for that, you need to do step by for every single compound that you need to do. Okay, so for my case, it's a little bit tricky. Is I have 2 different response, 2 different signals, right? So if I key in one range, you see the range is basically key in over. You go to report down up here, and you go to system suitability, edit noise ranges. Okay, and you see there's no like from and to. They don't distinguish for this range is from signal A or signal B. So basically this will apply for to both signal A and B. So basically if you key in a range of let's say 1 to 2 minutes, you have 2 different noises from both A and B. So that you kind of a little bit tricky over here to let the software use the correct number, right? So let me show you that. Okay. The first thing you want, I will start with CO2 over here. And for CO2, it's sitting on a slope right here. And most of the time, you don't want to key in so long range. Otherwise, the calculation will not be so accurate because it's sitting on a slope. So the noise will be much higher, right? So you don't want to use a very long range. So the first, I would look at the range somewhere here. So I would say I would go from 304 to probably 3.1 or 308, something like that. Okay, let me key in that. Okay, 3.04 and 3.08, something like this. You don't want to go for a long range for those peaks sitting on the slope like that. Okay, you want to, and then the second peak, which is a hydrogen right here. And this one is nice, it's sitting on the normal baseline here. So it's okay for you just to pick the noise somewhere from here. And for this one, you can go a little bit longer, that doesn't matter. You can go from 6 to 6.2 for this one. Can go 6 to 6.2. Okay, and then you have these 2 guys, argon and oxygen right here, and you see that they are sitting on like a hill over here. So you don't want to pick somewhere here, otherwise the noise here will be much better than the noise on top here. So that's not real. So you want to pick somewhere from here to represent better noise. Okay, I would go from again it's sitting on a slope, so I don't want to pick very long range. So I would go somewhere from maybe 8.25 to 8.3. 8.25, 8.3. Say okay. Okay, I have no two more picks. Nitrogen, let's look at it. Okay, I zoom in. Okay, nitrogen looks nice, so you can pick probably somewhere here. So you can go from 11.3 to 11.4, something like that. 11.3, 11.4. Then you want to zoom out again and look for the last pick, which is CO, right? Yeah. Okay, this is CO, and you see it's a nice baseline, so you can pick somewhere from here. That's fine. So I can go from 24.6 to 24.8 to 24.8. Okay. Okay, let me show you this. So you go to report, specify report, and then want to choose class reporting, and under report style you choose short. You go to performance plus noise. So here, say okay, and print a report for that one. I'll show you what I meant just now. Okay, let me maximize the window. Okay. Okay, so these are all the ranges that we key in just now, and you see that this one is signal A, and you remember signal A is the blue one, and the blue one we just need to look at CO2. But you see the way the software is doing, it will basically we just need the first range for signal A, but actually the software will perform a calculation for all ranges that we have keyed in just now, right? Because the software doesn't know which signal you want to use for calculation. That's why it will show up all, right? So that's what I meant just now. Okay. So it's quite tricky over here is, let's see, if you have a peak here and you have a peak over here. So if you select the range somewhere from here, it is closer to the peak of CO2. So that's means the software will pick that range and use for CO2, right? If you pick a range somewhere from here, it actually will use this range for this peak instead of CO2. Right, so that will be a little bit tricky over there. So when you select the ranges, you want to be a little bit more careful with that one, especially when you're working with multiple signals like this. But most of the time, you have only one signal, like FID or TC or something like that. That will be very easy. But when you want to be a little bit cautious when you have multiple signal like this, right? So let me close this window, and so that is the, go back to the formula, that's the noise. I'll show you how to use a noise in the calculation later on. So the peak width and height and the errors, everything will be inside the intelligent reporting. So let's start building the formula right now. So what I would do is, let me do like this. I will switch back this one to the short one, to return. Right? And what I would do, I would send it to intelligent reporting with all report layout. All right. Okay, so let's make a new template for that one, new report template down here. Then this will be single injection, because again, even you have 3 forums repeatable, but you just need to pick one of them for the calculation. That's why it will be single injection right here. Then say okay. Okay, so you can bring whatever fields that you like to have, like sample name, thing like that, or data file, whatever over here. But I'm not going to do that in this video, just to make sure we don't go over time with this one. So I'll just focus more on calculation. So let me pull all the table, the pick tables right here. So you go to tables, picks and compounds, and you have compound results over here. Bring one over, right? So there you go. Okay, so let's go to properties. Okay, so down here, what you need to have is a concentration. The threshold is 3, so let's start with the threshold. I can change the retention time over here. So instead of retention time, I can put it threshold, right? And the value is number 3 just now. We just enter 3 from here. Okay. So the next column is its concentration. So let's change the title on top here. Concentration. Okay. Then the formula, the concentration, a little bit tricky. Remember just now we store this concentration in the multiplier column, and in order for you to calculate that multiplier column, the formula is basically compound amount divided by peak area. and divide by compound response factor. All right, so that is a formula for you to calculate the multiplier column just now. Okay, so okay, then the next column is noise, so let's go into that. Noise. Okay, and for noise that will be okay, if you go to fields, then you go to pick, then you all the way down here, what do you have is you go to signal to noise USB over here. This is the closest one that is available in this software. So if you see the description over here, they say signal to noise is I mean, if you use this one, the formula you get is 2 h divided by Hn, and h is basically the peak height, and Hn is actually the difference between the largest and smallest noise, which is the noise, the peak-to-peak noise that you are seeing. So, so if I take this one and divide by 2, and that will give me h divided by Hn. I want Hn only, so that means I will take peak height and divide by this whole thing, and then I will be able to get my Hn, which is the noise that I'm looking at. Right. So this is my noise. I say okay. To the next column. Let's say noise width at half height. So that will be so let's say something like this, and that will be, let's remove the formula. And if you go to fields again, and you go to pick, and you go to somewhere down here, okay, width 50%, right? It's right here, 50% right here. Let's say double click on it. So there you have the pick width at half height, right? And then the next one is the error count, so that would be area, and the formula down here, you can type pick area down here, or you can go to fields and you go to pick and you select pick area on top here. So that's the same thing. All right, so that's everything that we have. Let's look at the report. And okay, so you have the name over here, then you have threshold of 3 in the formula, then you have the concentration, which is 10. You see the formula we put in just now. Remember, I entered N for 10 for everything, so that's why it's 10 over here. Then noise automatically pick up by the Chemstation as long as you keep the range just now that we did. Then you have a pick width at half height over here. Then you have the error count. So everything you have that, then you just need to plug everything into this formula. So that will give you the detection limit. Okay, so let me do that right now. Go to properties again. You want to add a new column, which is you can change the name and you put that one as LOD. So will be LOD. All right, the formula will be go back to this one, 3 times concentration. Again, let me open and close the bracket right here. So concentration again, that will be compound amount, or you just copy the formula just now we enter in the compound in the concentration column just now. Otherwise, you can key in one more time from here so that you will get used to this kind of formula. Okay, response factor, right? So that is your compound amount, and then you have the noise. Again, noise will be time. So noise, for the noise, you want to go to field, go down here again, which will be right here, signal to noise USB. Okay, this one, you want to have peak height, divide by this, and you put all together here, and this one need to be divided by 2, right? Right. So there you have the noise, and then we have 60 times 60, and then time width at half height over there. So just look at one more time right here, and then the final ones divide by peak area, right? So peak area, there you go. So you have like this. All right, so you can go to value format and you change that one. Do you want to have a little bit, maybe 3 decimal places, and then peak area 3, that's fine. Peak width at half height, noise, you want to increase a little bit more, you want to something like that. Okay, say okay, say okay, and then you want to review your report. Right, so LOD is calculated right here, as you see, like that. And in terms of the unit, let me show you what unit that should be over here. So let me show you the formula right here. So you see the error count is typically the unit is signal times second, right? And peak width at half height times 60, this is second over here. So second cancel out. Noise is the same as signal, like picoampere. So this one also picoampere times second, picoampere times second over here, so cancel each other, right? So actually LOD is the same unit as a concentration, is formula. So that's why whatever concentrate formula unit that you have for the concentration column over here, you have the same over here. So in my case, this is ppm, so I get ppm here as well, right? So that will be your LOD. Okay, so once you're happy with the calculation, you can save the template. You can make things a little bit nicer here and there a little bit. Then what you need to do, just save the template. You can call it whatever name you like. So let me put LOD area, something like this. It's saved. Okay, then I go back to data analysis, and what I would do is I select the data that I want. Again, you have four different data over here. Just pick one of them. It doesn't matter which one. You go to specify report. Now you want to use something called use intelligent reporting. Okay, then you go to browse the one on top here, report template, and you select the template just now. You save, and that one was LOD error right there. Say okay, and then so one more point is very important. Is just now you see the multiplier column that I showed you just now. I was using like compound amount divided by peak error divided by compound response factor to calculate this multiplier column, and that will only be true if you are using ESTD over here, right? So make sure that you choose ESTD in the calculation mode under here, right? Say okay, and then you should be good to print a report. There you go. You'll see that you get this kind of report right here, and you see it's already everything calculated like this. And you can also, if you want to pick another data, let's say you want to pick this one, you can also do the same thing. Just hit the print report, and everything will come out automatically for you. And if you notice a number, actually they are actually very close to each other and very similar in terms of the LV calculation here because they are repeatable, right? All right. So that's all I have for this video. I think it's a useful video for you to add on more like a couple of ways to calculate the detection limit, because so far we have covered like signal to noise approach for this one, and then we also have the 3 times standard deviation approach. So I put everything together in a single playlist so that it's easier for you to refer back anytime, right? So I put the link for those videos in the description as well at the end of the video as well. So thank you very much for watching. I hope you enjoyed it. If you have any question or anything, let me know in the comment below. And don't forget to subscribe to my channel. Thank you very much. Bye bye.